This is Chapter 16, Identifying the Missing Part of a Nuclear Reaction, Introductory Chemistry at Mineral Area College. So just to start off this video, I just have a couple of problems for you guys to solve with the nuclear reactions. And so in order to solve these problems, all we got to do is just make sure that the total mass number on the left side is going to be the same as the total mass number on the right side. And also the total atomic number is going to be equal to the total atomic number on the right side. And so let's get started. On example 1, we have sodium, and we know that the atomic number is 11. And so we need to add something to 1 to make sure that it's 11, and that's going to be 10. 10 on the periodic table is neon. It's going to be 22 for the mass number of neon because we have 22 on the left side, and so 22 plus 0 is going to be 22. And so it's just going to be 22 over 10 for neon. And so example 2, we have iron reacting with a neutron. We know that 26 plus 0 is going to be 26. And so over here on the right side, the atomic number is going to be 26 as well. And that's just going to be iron from the periodic table. We know that the mass is going to be different this time because it's going to be 58 plus 1, which is 59. So it's just going to be 59 over 26 for iron. On the third example, we have radon reacting with a alpha particle, and so we have 86 plus 2, which is 88, so we need to find the element with the atomic number 88, and so that's just going to be radium. And so we know that the mass number is going to be different from the periodic table, however, because we have 226 plus 4, so the mass number is just going to be 230, and then it's going to be over 88 for radium. Next, we have argon with an electron capture. And so we have 18 minus 1, which is going to be 17. 17 on the periodic table is going to be chlorine. Then we have 37 plus 0, which is going to be 37. And so it's going to be 37 over 17 for chlorine. Next, we have aluminum reacting with a alpha particle, produces something we don't know yet, and a neutron. So we know that 13 plus 2 is going to be 15. So the total atomic number over on the left side is going to be 15. Total atomic number on the right side must be 15 as well. We know that if this was 15 plus 0, then it would just still be 15. So we can assume that the atomic number for this missing part is going to be 15. 15 in the periodic table is going to be phosphorus. We know that 27 plus 4 is just going to be 31. And then we know that something plus 1 has to equal 31, right? And that number can only be 30 because 31 minus 1 is going to be 30. And so the answer is going to be 30 over 15 for phosphorus. And so the final example, we have this weird sort of equation, right? And so in order to solve this, we have to think about it critically. So we know that 1 plus something is going, or 1 minus something potentially has to equal 0. Well, the only viable answer is just going to be minus, right? Because if you add something, that's going to get you farther away from 0. So if we subtract something from 1, is going to make us have 0, and so we know that it's going to have to be a negative number. And the only thing that we have worked with so far that has a negative number at the bottom is just going to be this electron capture. And so it's actually going to be the answer because we know that 1 minus 1 is 0, so that's the total atomic number on the left side. On the right side, it's going to be 0 for the neutron as well. And then we know that with how electron capture works and the symbol of it, we know that 1 plus 0 is going to be 1, and we still have 1 over here. And so that's why the answer is going to be an electron capture. Thank you for watching.